In this video, we will talk about how to write explicit formulas for geometric sequences. So I have two examples for us to work through here. Let's check out the first one. Let's say we have the following sequence of values, and we want to write an explicit formula to describe how to get the nth value in the sequence. The formula that we can use is right here. A sub n is equal to a sub 1 times r to the power of n minus 1, where a sub 1 is just the first value in the sequence, and r is the common ratio between the values. So to write an explicit formula for this sequence right here, we can say a sub n is equal to, now a sub 1, that would be this first value in the sequence. So this 5 right here. So a sub 2 would be the next value, then a sub 3, a sub 4, a sub 5. So we could label them in this way. So the first thing that we need to write is a sub 1, which is just this 5 right here. So we'll say 5 times r. Now r is the common ratio between the values. So the way that we find that is just pick any value in the sequence and divide it by the previous value. So let's say we pick this 10 right here. All we have to do is divide it by the previous value, the 5. So we'll say 10 divided by 5. What is that? That's 2. So the common ratio is 2. And the nice thing about this is that you can pick any value in this sequence and you can still find the common ratio. So let's say we instead picked a4, this value over here, and we divided it by the previous value of 20. Well, we would have 40 divided by 20. That's still 2. So it doesn't matter which values you pick. You just pick any value in the sequence and divide it by the previous value, and that will get you the common ratio. So for r, we'll write a 2 right here in parentheses, and we'll say n minus 1. And this is our final answer. This is the explicit formula that we can use to find the nth term in this sequence. So to double check that we got the right answer, let's pick a value for n and see if we get the corresponding value up here. So let's say we want to find the third term in the sequence, so a sub 3. Let's see if this formula actually works. It says multiply 5 times 2 to the power of, for n we're plugging in a 3, so 3 minus 1. So what is that? We get 5 times 3 minus 1 is 2, so 2 squared, that's 2 times 2, that's 4. So we get 5 times 4, which is equal to 20. So we can verify that yes, a3 is indeed equal to 20. And another thing that we can do is we can use this formula to find the nth value or any value we want in the sequence. So let's say we wanted to find a sub 6. According to this formula, it says a sub 6 is equal to 5 times 2. And we'll plug in a 6 for n right here. So 6 minus 1. So let's see what that is. So we get 5 times 6 minus 1 is 5, so 2 to the 5th, that would be 32. So we put 32 right here. 5 times 32, that turns out to be 160. So that would be 160 right here. And we can see that this is the correct answer because to get the next value in the sequence, we're just multiplying by 2. So 5 times 2 is 10, 10 times 2 is 20. So if we have a5 over here and we want to get a6, 80 times 2 is indeed equal to 160. So we know that we got the right answer. All right, let's try one more example. Let's say we have the following geometric sequence and we want to write an explicit formula to find the nth term in the sequence. So we'll just use this formula, this format right here again. So we'll say a sub n is equal to a sub 1. Remember the first value in the sequence is a sub 1. Then we have a sub 2, a sub 3, a sub 4. This would be a sub 5. So a sub 1 we can see is 8. So we'll write 8 times r. R is the common ratio. So remember to find that, just pick any value in the sequence and divide by the previous value. So let's say we pick 4 and we want to divide by the previous value of 8. Let's see what we get. 4 divided by 8, that can be reduced to 1/2. So r, the common ratio, is 1/2. So we'll write 1/2 right here to the power of n minus 1. And this is our final answer. This is the explicit formula we can use to find the nth term in this sequence. And to verify that we got the right answer, let's just pick a value for n. So let's pick 3. So we'll say a sub 3 is equal to 8 times 1/2. And we're going to plug in a 3 for n right here. So 3 minus 1. So 3 minus 1, that's 2. So we get 8 times 1/2 to the power of 2. 1/2 to the power of 2, remember we can think of that as 1/2 times 1/2. And when we have fractions like this, we can multiply straight across. So 1 times 1 is 1. 2 times 2 is 4. So 1/2 squared is 1/4. So we really get 8 times 1/4, or in other words, 8 divided by 4, that would be 2. So a sub 3 is equal to 2, and that matches the a sub 3 and our sequence up here. So that's just a way to verify that we got the correct answer.